Hello students, welcome you all. So today we are going to discuss rational numbers. So first of all, we are going to discuss what are rational numbers. So the word rational arises from the term ratio, and you know what is ratio. In the previous class we had discussed about ratio. So ratio, for example, we can write like 3:2, and you know that 3:2 can also be written in the form of 3/2 or 3/2. So here you can see both 3 and 2 are both natural numbers. Okay. Now we'll move to what a rational number. In a rational number, which a number can be told a rational number when it can be written in the form of p by q. Okay. Any number that can be written in the form of p by q. So this is the first concept. Second concept is p and q are integer. P and Q are integer. So this is the first concept. First concept is P by Q form. Second concept is P and Q are integers, and the third concept will be Q not equal to 0. So the three condition: first condition P by Q form, any number that can be written in the form of P by Q. Second condition P and Q are integers, and third condition is Q not equal to 0. So we will take some examples. So let's take an example 2 by 3. So here you can see 2 by 3. It can be written in the form of P by Q. P and Q are integer, 2 and 3 are integer. Q not equal to 0, that means 3 is not equal to 0. So yes, it is an rational number. Now we will take, so suppose 7. Now can 7 be written in the form of P by Q? Yes, we know that 7 equal to 7 by 1. So we can say 7 by 1. We have written this 7 into 7 by 1 P by Q form. Then P and Q are integer. So 7 and 1 both are integers. Yes. Q not equal to 0. That means 1. 1 is not equal to 0. So yes, 7 by 1 or 7 is also an rational number. Now we'll take another example. So suppose minus 7 by 3. So can this be a rational number? Yes, why not? P by Q form. Yes, there is P by Q form. P and Q are integer. Yes, minus 7 is an integer and 3 is also integer. Q not equal to 0. Yes, it is 3 not equal to 0. Now can you say 8 by 0 is an integer? P by Q. Yes, P by Q. P and Q integer. Yes, 8 and 0 are integer. Q not equal to 0. But here you can see in the denominator there is 0. So you can say it is not a rational number. So 8 by 0 is not a rational number. Now we will take another example. So suppose 0. Now can 0 be a rational number? Okay, let's see. 0 will be equal to, we can write 0 in the form of 0 by, say suppose 2, or 0 by 3, 0 by 4, 0 by 5. All are equal. 0 by any number equal to 0. Now 0 can be written, so you can say 0 equal to 0 by 2. Okay, or you can write 0 by 3, 0 by 4. So here you can see P by Q form. It is satisfying the first condition. Second condition, P and Q are integer, 0 and 2 are integer. Okay, Q not equal to 0. Q means here it is 2, 2 is not equal to 0. So you can say 0 is a rational number. Okay, so we got several examples, and we found what are rational number and what are not rational numbers. Okay, so these are the examples of rational numbers. Now we'll move to the next part, that is numerator and denominator. So you know, in a rational number that we can write in the form of P by Q. Okay, where P and Q are integers and Q not equal to 0. Here P is called the numerator and Q is the denominator. Okay, so numerator is the number which is there here, this one, and Q is the denominator. Okay, so you know that numerator and denominator from class 5 and class 4 also. Now we will see are integers also. Yes, we have already discussed integers are also in rational number. Like we had taken 7. 7 is equal to 7 by 1. So we can say 7 is also a rational number. We have also discussed it. 0 is also a rational number. 0 by 2 or 0 by 7. These are also rational numbers. Okay, now we'll move to equivalent rational number. You know that how to find equivalent fraction. You know how to find equivalent fractions. Now finding equivalent fraction is literally same as finding rational numbers also. So let's try to find some equivalent rational numbers. Okay, so we will take for example minus 2 by 3 here. Okay, we will take minus 2 by 3. So it is a rational number. Now it will be equal to minus 2 by 3 into 2 by 2, you can say, or into 2. In the denominator also we are multiplying 2. So it will be equal to minus 4 by 3 to is 6. We can say minus 2 by 3 is an equivalent rational number of minus 4 by 6, or the vice versa. That is, minus 4 by 6 is an equivalent rational number of minus 2 by 3. So we can find several other equivalent rational number also, like we like 2 by 3 minus 2 by 3, which will be equal to minus 2 by 3. Here we had multiplied 2 by 2, or we can multiply 3 by 3 also. So it will be equal to 3 2 is minus 3 into minus 2 will be minus 6 divided by, here 3 3 is 9. We can say that minus 2 by 3 is equal to minus 4 by 6, which is also equal to minus 6 by 9. Okay, so they are the equivalent rational number. So same type of equivalent rational number you have studied in finding equivalent fractions also. Okay, so now this is the way you can find the equivalent rational numbers. Now we'll move to positive and negative rational numbers. Very simple. We will take an example. Say suppose same 2 by 3. Now you can say 2 by 3 is a positive rational number. Now if we write minus 2 by 3, then we can say it is a negative rational number. Or in other words, if you write 2 by minus 3, here we write 2 by minus 3 minus 3, we can say it will be a negative rational number. Okay. So where we will say a rational number is a positive rational number, when that both the numerator and denominator are positive. Now when we say a negative rational number is a negative rational number, when either the numerator or the denominator is negative. But here another concept arises. Suppose you will write minus 2 by minus 3. What it will be? Here in this case minus minus will be cancelled. It will be equal to 2 by 3. That means we can say minus 2 by minus 3 is a positive rational number. Okay, as it is equal to 2 by 3. Okay na? So these are the basics of positive and negative rational number. Okay, another thing about negative rational number is, suppose you are writing 2 by minus 3. It will be written as minus 2 by 3, as 2 upon minus 3 is equal to minus 2 upon 3. Okay, as both are, the value of both are same. So basically the standard form of writing a rational number is minus 2 by 3. Okay, so this is not the standard form, this is the standard form, but this is not incorrect also. This is also correct, this is also correct, but this is a standard form. Now we will move to rational number on a number line. You know how to put integers on a number line. Normally we draw a straight line. In the middle we write 0. Towards right we write 1, 2, 3, 4 with equal space. That means this space must be equal in length. Then similarly towards left we write minus 1, minus 2, minus 3 and minus 4, etc. Okay. So here, so this is the way to represent the integers on a number line. Now we will see how to represent a rational number. Okay. Suppose we will take an example of 1 by 2. We will represent 1 by 2 on a number line. You know that 1 by 2 means we have to divide a part into two part, and we will take one part. So here that means out of 2 part we will take one part. So here in 0 to 1 we have to divide 0 to 1 to 2 part like this, and we will take this much part. So we can demark the point and we will say if this point is 1 by 2. Similarly we can put or demark minus 1 by 2. Same. So minus 1 by 2 means out of 2 part you have to take minus 1 part. So we will first create 2 part and we have to take minus 1 part. So from in 0 to minus 1, this area will demark a point. As we have divided 0 to minus 1 into 2 equal part, here this point will be minus 1 by 2. Okay, now we will take another example. Suppose we have to demark, say suppose 7 by 3. Okay, 7 by 3 on a number line. How will divide it? Now out of 3 part we have to take 7 part from. So this is a positive rational number. So we will first divide 3 part in 0 to 1. 1, 2, 3, 3 equal part. Now we have to take 7 part. Only 1, 2, 3 parts are there. Then 1 to 2 have to divide another 3 part. 1, 2, 3. Now we can count 1, 2, 3, 4, 5, 6 parts only. But we need 7 parts. So we have to further divide 2 to 3 into 3 parts. Now 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So this point will be 7 upon 3. Okay. Similarly, if you want to demarcate minus 7 upon 3, what we can write? You see, same story. Out of 3 part we have to take minus 7 part. So same 1, 2, as it is in minus, we have to move towards left of 0. So 1, 2, 3 part only. Then again minus 1 to minus 2 we have to divide 3 part. 1, 2, 3. So 3, 3, 6. Then again minus 2 to minus 3. Again 3 part. So we have here 3 part, here 3 part, 3, 3, 6, 1 part. So this point will be minus 7 upon 3. Okay, or minus 7 by 3. So in this way we can represent rational numbers on a number line. So now we will move to the next one, that is rational number in a standard form. Okay, so basically I have already discussed about it, rational number in a standard form. So here are some rational numbers. 3 by 5. Now we can say 3 by 5 is in a standard form. Why? 3 by 5. Okay, you know which fraction or which rational number is in a standard form? When the numerator and the denominator do not have any common factor. So you can see 3 and 5 have no common factor. So we can say 3 upon 5 or 3 by 5 is in a standard form. Okay. Similarly, we can take minus 5 by 8. Same story here. 5 and 8 both have no common factor, so that we can say minus 5 by 8 is in a standard form. If we write 5 upon minus 8, so can it be told in a standard form? No, it is not in a standard form. So in order to be a rational number in a standard form, the negative sign need to be there in the numerator, not in the denominator. If it is in denominator, we can't say that rational number is in a standard form. So this is one concept, you need to memorize it. So minus 5 by 8 will be in a standard form. If the rational number is like this, 5 by minus 8, so we have to convert it as 5 by minus 8 is equal to minus 5 by 8. Basically both are same. Okay. So this is all about standard form. Now we will move to comparison of rational numbers. So for this we can take two positive rational number. We will move to negative rational number later. So first we will take two positive rational number like 2 by 3 and 5 by 7. Now you studied earlier in the fractions, okay, how to compare them, compare fractions. So in the same way we will compare the rational numbers. So first of all we will take, so for example, 2 by 3 and then 5 by 7. You can see in both the case the denominators are 3 and 7, and what we are doing there, we are finding the LCM of these denominators. So LCM of 7 and 3 is, 7 and 3 LCM is 21. So first of all we will take 2 by 3, which will be equal to 2 by 3 into we can multiply 7, here also 7, so it will be equal to 14 by 21. Similarly we will take 5 by 7, here 5 by 7, which will be equal to again 5 by 7 into 3 by 3 you can multiply, So it will be equal to 15 by 21. Now you can see 14 by 21 and 15 by 21. Who is greater? You can write 14 by 21 is smaller than 15 by 21. Therefore, 14 by 21 is equal to 2 by 3. So you can say 2 by 3 is smaller than 5 by 7, as 15 by 21 is equal to 5 by 7. So this was the method that we are using in case of fractions, and in the same way we are going to do that in also the rational numbers. Now if these numbers are negative, then what will happen? Here you can see, we will take, say, suppose these are negative, okay, minus 2 by 3 and minus 5 by 7. Same, you will just put negative signs, minus 2 by 3, here it will be minus, here it will be minus, here same, minus and minus, and here the story will little bit change. What will change? See, first we will see, we will try with a number. Suppose 2 and 3 are there. You know that 2 is smaller than 3, but when there is minus 2 and minus 3, who is smaller? Minus 2 is greater than minus 3, okay. So you can write minus 2 is greater than minus 3. When the sign changes, the small number is becoming the large number here, okay. So this is it. Now in the same way, here you can see what will happen. Minus 14 by 21 and minus 15 by 21 is here. So minus, here it will minus, here it will minus. So minus 14 by 21 will be greater than minus 15 by 21. Therefore, so who is equal to minus 14 by 21? Minus 2 by 3. So you can see minus 2 by 3 will be greater than minus 5 by 7, as minus 15 by 21 equal to minus 5 by 7. Okay. So we will take another example to make it little bit clear. So here you can take minus 1 by 2 and minus 1 by 5. Here you can see 2 and 5 are the denominator. Therefore, the LCM will be 2 into 5, that is equal to 10. Now we will write minus 1 by 2 is equal to minus 1 by 2 into 5 by 5. So it will be equal to minus 5 by 10. Again, minus 1 by 5 is equal to minus 1 by 5 into here it will be 2 by 2. So it will be equal to minus 2 by 10. Now you can see minus 5 by 10 and minus 2 by 10. Again I will give you that example. Suppose minus 2 and minus 3 are there. Who is greater? Definitely minus 2 is greater. When they are positive 2 and 3, the reverse happens. Okay. Same story will be repeating here. Minus 5 by 10 and minus 2 by 10. So you can write minus 5 by 10 is smaller. It will be smaller than minus 2 by 10. So minus 5 by 10 equal to minus 1 by 2. Minus 1 by 2 will be smaller than minus 1 by 5. So this is the whole story, and this is the way you can proceed to find or to compare two rational numbers. Now we will move to the next part, rational numbers between two rational numbers. So before moving to rational number, we can take example of integers. Suppose you are taking integer 2 and 3. Now how many numbers of integer are between 2 and 3? You can see 2, then exactly after 2 there is 3. So there is no integer. We can say 0. No integers are there in between 2 and 3. But when we come to fractions or rational numbers, how many rational numbers are between 2 and 3? There are infinity. Okay, infinite number of rational numbers are between 2 and 3. So we'll take one example for this. Suppose we will have to find rational numbers between minus 3 by 5 and minus 1 by 3. Okay. So for this, what we are doing, remember what we are doing in the fractions case, we are identifying the denominators. So in this case, the denominators are 5 and 3. So you are used to find the LCM of these denominators. So LCM of 5 and 3, you know that they don't have any common factors. So therefore we can say the LCM will be 5 into 3, that is 15. Now what we will do, we will convert the denominators, here it is 5 to 15. and 3 here, 2 also 15. Okay, so let's start it. Now first of all we will take this one, minus 3 by 5. So minus 3 by 5 is equal to, we can write it here, minus 3 by 5 is equal to minus 3 by 5 into what will multiply? We will multiply 3 upon 3, which will be equal to minus 9 by 15. So it is directly written that minus 3 by 5 is equal to minus 9 by 15. And similarly minus 1 by 3, minus 1 by 3 will be equal to minus 1 by 3 into how much we will multiply? 5 upon 5, which will be equal to minus 5 by 15. So here it is written minus 5 by 15. Now we have minus 9 by 15 and minus 5 by 15. So in between minus 9 by 15 and minus 5 by 15, who are the rational numbers? These are the rational numbers. Minus 9 by 15 will be smaller than minus 8 by 15, smaller than minus 7 by 15, smaller than minus 6 by 15, smaller than minus 5 by 7. This number 5 by 15, minus 5 by 15. So in other words, we can write this minus 9 by 15 as minus 9 by 15 is equal to minus 3 by 5. So instead of minus 9 by 15, we will write minus 3 by 5. So here you can write minus 3 by 5 and rest are same. Minus 8 by 15 here, minus 7 by 15 here, minus 6 by 15 here, and minus 5 by 15. This is equal to minus 1 by 3. So you can say minus 1 by 3. So this is the way we can convert the we can compare the rational numbers. So basically these are same with your fractions. Well, one more thing is here, that is when we compare, suppose 2 by 3 and minus 1 by 5. Here in this case, you don't need to compare, you don't need to equal the denominators. Directly you can write 2 by 3 is greater than minus 1 by 5. Why? As that here it is positive in rational number, here it is a negative rational number, and clearly we know that the positive rational number will be greater than the negative rational number. Okay, so this is it. We have discussed the introduction part. Now we will move to the exercise part in the next class. Okay, thank you.